Okay, this little video is about central and inscribed angles. So two different angles that are we find often associated with circles. And so the first one is called a central angle. And what a central angle is it's an angle whose vertex is at the center of a circle. And I happen to have one right here. So this angle right here is a central angle. So if we were to take this angle right here, that. Okay. So a central angle, what you need to know about it is that it is equal to the measure of its included arc. So what the heck does that mean? That means that this angle right here, let's say this angle is like 87 degrees. That means that the measurement of this arc right here is also 87 degrees. So the central angle and the arc are the same. And then over here I have a little picture of a piece of pizza. So here's our central angle right there. And so that means that the angle of this arc, the crust, is equal to the measure of the angle where the part of the pizza you usually eat first is. Okay, so if this is like, I don't know, let's say 25 degrees down in here. If this is 25 degrees in here, and then this out here is also 25 degrees of the circle. So, not too tricky. Let's look at the next one. The next one is called an inscribed angle. And an inscribed angle is an angle whose vertex is on, sorry, it should say is right there. Let me fix that real quick. Is on the circumference of the circle and extends out to the across the circle. So the best way to see what an inscribed angle is really just to see one. So you can go ahead and copy this down, but this is really what it looks like. Make sure you draw this picture. Okay. So here's an inscribed angle. So notice that the vertex is on the circumference of the circle. So the vertex is over here, and it opens and it goes across the circle like that. Okay, so it goes over here. Okay, now an inscribed angle is half the measure of its included arc. Okay, so it's half the measure of its included arc. Make sure that you know this. This is the key part. Okay, so what that means is that if this arc right here is, let's say that's about, let's say this is about 90 degrees of the circle. Let's say that this arc is about 90 degrees of the circle. Well, this down here is half of that. So that would make this 90 divided by 2, or 45 degrees. So our inscribed angle down here is 45 degrees. And that's the concept. Essentially, let me make this a little darker for you. This angle is always half of the arc here. We call this an included arc. I've been throwing that thing out. What that means is basically the angle is like surrounding the arc here. So that as the rays of the angles go out, the arc is in between it there. So if this is 90, then this is 45. If this is 100, if this is 100, then this is 50. If this is 120, then this is 60. So this is always half of this. Okay. Let's look at some example problems. So here's some example problems. So number one, it says find the measure of angle A. Okay, so here we have 38 degrees for our arc BC here. So we know that arc BC is 38 degrees, measure of it. Okay, and we want to find out the measure of angle A. Well, because this is a central angle here, it's a central angle. Because it's a central angle, that means that it is the same measurement as the outside, so this is also 38 degrees. Alright? So the measure of angle A is the same as the arc, so it's 38 degrees. Number 2. Number 2, find the measure of angle Q. Okay, so angle Q is this one here. And then we have the arc RS is 120 degrees. So we have the measure of arc RS is 120 degrees. So then what we have to do is figure out what kind of angle this is in here. Let me switch colors. So this angle here looks like an inscribed angle to me. So this one's an inscribed angle. Okay, so that means that it's going to be half of its arc. So that means if we take this number and divide it by 2, we're going to get the arc. So 120 divided by 2 equals 60 degrees. So that means that this is 60 degrees in here. So we do that divided by 2, so we get the measure of angle Q equals 60 degrees. Okay. That's pretty much all there is to it.